Hi guys, welcome back to Worms Maths Academy. Rarely do I get really serious when I'm teaching something, but this thing here is something to get serious about because they keep doing this over and over every year, composite functions. And most kids seem to struggle with it, and it stuffs you up for exam 1 and exam 2. So, composite functions. So we've seen before, you can have addition of two functions, f plus g of x, and their domain is where they intersect. And that's the same when we multiply two functions together. Okay, so this is the sum or addition of two functions, and this is the product. Well, composite functions are neither of those. Composite functions are when you have a function inside another function. If you've done a bit of differentiation before, you probably learned the chain rule, which you use with composite functions. But to create a composite function, a few things need to occur. So what we're going to look at now, we've got f of x is 4x minus 5, and g of x is x squared. Now I want to work out fog, f-o-g, of x is the same as f of g of x. If it's an O, not a dot, if it's a dot then it's multiplying. So f of g of x, so f of g of x, or we call that fog of x. So if you have h of g of x, then you call that hog of x. Okay, now to work out fog and goff, firstly, fog, we know f of g of x is x squared. That means wherever I've got an x in f of x, I replace it with an x squared. So I get 4x squared minus 5. That's nice and simple. So that's what f of g of x is. I think I just rubbed out my circle. There was a circle there, like the other side. Okay, so that's f of g of x, and then g of f of x, that means g of 4x minus 5, which means wherever I've got an x in g, I replace it with a 4x minus 5, which will give me squared. You can expand it, 16x squared minus 40x plus 25. I probably wouldn't expand it, you could leave it either way. Now, pretty simple. Well, it seems like it's pretty simple. However, what we need to do for this to be official is we need to check a few things. So firstly, what's the domain and range of that function? Well, we can use any real number for the domain, and because it's a straight line, its range is all real values. G of x is x squared, that's also got a domain of all reals. However, the range on x squared is 0 to infinity. Now, if you have a look down here, I've said here, for fog to exist, the range of G must be a subset of the domain of f. So subset means fit into. So the range of G must fit into the domain of f. If it exists, the domain will be the domain of G. So before we create fog, we've got to see if, so here for fog, the range of G must be a subset of the domain of f. So what's the range of G? The range of G is this. Does 0 to infinity fit into all real numbers? Yes, it definitely does. Everything fits into all real numbers. When we're just in methods, everything will fit into all real numbers. So then we can say f of g of x is f of g of x, which is f of x squared, which we know is 4x squared minus 5. Now it says if fog exists, its domain will be the domain of G. So our domain is all real numbers. Okay? G of f of x. Well, here if I want to find g of f of x, the range of f, the second function, or we can also call that the inner function, so the one that's in the brackets, the range of f must be a subset of the domain of G. So does all real numbers fit into all real numbers? Well, it's a subset because they're the same thing. So here, G of f of x, which is 4x minus 5, we can write that as, we've got x squared, we replace it with a 4x minus 5 squared, and then its domain is the domain of the inner function, which is f, and that's also all reals. So x is an element of all reals. Now, we started off with some nice and easy ones, just so that you can get the idea. But for Fogs and Goff to work, the range of the inner function, so G is the inner function in this case, must be a subset of the domain of the outer function. If it does, then the domain will be the domain of G. Okay, however, if f is the inner function, the range of f must be a subset of the domain of G. So that means that the range of the inner function still has to be a subset of the domain of the outer function. If it exists, it's going to be the domain of the inner function. This is just showing you how to put it into the CAS. When you graph it, the CAS will actually work out the domains and ranges for you when it graphs it, but you need to know how to do it by hand. So let's have a look here. If f of x is that, and g of x is that, find g of f of x if it exists, and f of g of x if it exists. So this is what I want you to do every single time. I want you to write the domain and range of both functions. So I've got a linear function, domain's all reals, range is all reals. We've got a square root function, that's from 0 to infinity, and its range is from 0 to infinity. So that's your domain and your range. If I want to find g of f of x, we've got to see is the range of f of x a subset of the domain of g of x. Oh, so I forgot the g of x. Okay, so the range of f of x is all reals. Is that a subset of 0 to infinity? No. So, as the range, and you have to state this, of f of x is not a subset of the domain of g of x, then g of f of x is not defined. Now I'll tell you why. So you should do this here to show, and then you should make this statement. Now I'm just going to get rid of this so I can show you why. If we think about the function f of x, which is 9x minus 4. So it goes through minus 4 and it's got a gradient of 9. So it goes up like that and down like that. It's got a steep gradient. Okay, this thing here, what values does it produce? Well, if x is 1, it's going to equal 5. 1, 5. If x is negative 1, I'm going to get negative 13. Negative 1, negative 13. So because this range here produces values like this one, negative 13, if I try and sub negative 13 into here, what happens? It won't work. You can't square root a negative number. So that's why Goff doesn't exist, because f produces negative numbers and we can't square root negative numbers. If f only produced positive numbers, then this would definitely work, but it doesn't because f produces negative numbers. So that's why Goff doesn't exist. However, let's look at Fog. F of g of x, so the range of g of x, is that a subset of the domain of f of x? So is 0 to infinity a subset of all reals? Yes, it is. Yes, it is. Therefore, f of g of x is defined. And f of g of x is f of root x, which is 9 root x minus 4. And our domain is just the domain of the inner function. So it's the domain of g of x. So x is an element of 0 to infinity, which is this thing here, because it's always the domain of the inner function. Now this makes sense. We can sub in 0. 9 times 0 is 0 minus 4 is minus 4. So this is f of g of x, and it's defined for all real positive numbers or 0. Because those numbers, the numbers that are spat out by this function, are okay to go into this function. There's no values that I can't use with f of x. Okay, so let's have another try. State why gof is not defined. So is this the same question? No, it's similar. Okay, so state why gof is not defined. So firstly here, my domain for f is all reals, and my range is -4 to infinity. And then g of x is 0 to infinity. And then my range is 0 to infinity. So why is gof not defined? So let's see, the range of f of x is a subset of the domain of g of x. So the range of f of x is -4 to infinity. Is that a subset of the domain of g of x? No. So the range of f of x, which is -4 to infinity, is not a subset of the domain of g of x, which is 0 to infinity. Therefore, g of f of x is not defined. Now, if you think about it, if you look here, the issue is because it goes from -4 to infinity, we want it to go from 0 to infinity. So it says here, define a restriction f star of f of x such that g of f star of x is defined, and then find g of f star of x stating its domain and range. So like we said, we want f to have a range of 0 to infinity, and we need to work out the domain that makes that occur. Because if it's from 0 to infinity, f star, that will fit into that, and then the function will work. So the composite function will work. So let's have a look. We know that this function, 9x squared minus 4, has to be greater than or equal to 0, because that's the domain, that's the range that we want to have. So that's our range of this function. And then the range will be a subset of the domain of g, and it'll work. Now, when we have an equation like this, we can't bring the 4 to the other side and then simplify. We've got to use a difference of 2 squares. So we get 3x plus 2, 3x minus 2 is greater than or equal to 0. Now, when we've got an inequality, we need to sketch it. So there's 2/3, -2/3. It's a happy face. So when x is less than or equal to -2/3, or x is greater than or equal to 2/3, then our range will be from 0, so here from 0 to infinity. All right, so if we restrict x to be between -2/3 and -infinity, or 2/3 to infinity, then our range is going to be 0 to infinity. So here, when we say our domain, we say -infinity to -2/3, or 2/3 to infinity. And then what that does is it creates a range of 0 to infinity. And then, if we know g of x, the domain is 0 to infinity, you can see now that that will fit in here. And then my range will still be 0 to infinity. So it says define a restriction, so that's our restriction, and then find g of f of x. So let's say g of f of x, g, what was f of x again? 9x squared minus 4, which is square root 9x squared minus 4. So that's g of f of x. And our domain is the domain of the inner function. So it's the domain of this function, which we've just restricted to be from x as an element of negative infinity to negative 2/3, or 2/3, oops, we can include 2/3, 2/3 to infinity. And what you'll see now, if we put any values in here into this function, it'll end up being 0 or positive. So if I put negative 2/3 in, negative 2/3 squared is going to give us 4 on 9. When I multiply it by 9, I get 4. 4 minus 4 is 0. So this function itself, if I use these values, I know if I put in, let's say 2/3, we get 0. So that's our lowest value. If we put in a bigger number like 1, I get 9 times 1 squared minus 4, which is 5. So the function is just going to get bigger and bigger. So my range is from 0 inclusive, because when x equals 2/3 or negative 2/3, this will equal 0, up until infinity. So this is g of f star. So g of f star of x, and that allows us to use this function, substitute into this function, because we restricted the domain of f to be from negative infinity to 2/3, negative 2/3 or 2/3 to infinity, and that restricts our range so that it'll then fit into the domain of g of x. Hopefully you get it. It's pretty tricky. Okay, so this is an exam question. They actually had 2 or 3 questions like this on a Calc 3 exam. So it shows the importance of knowing and understanding composite functions. Okay, so here we've got a function. It's defined from 0 to infinity. So don't just assume it's a maximal domain. Here it's from 0 to infinity. So if I was to put in 0, I would get 1. If I was to put in 1, I would get root 2. So it's going to be increasing. So our range of f is, we start from 1 to infinity. Let g from negative infinity to c, from the real number set, be this function here, and c is less than 0. Okay? Find the largest possible value of c such that range of g is a subset of the domain of f. Okay, so we've got g of x. We don't know what its range is at the moment, so we can find that if we want to. Complete the square, so x squared plus 4x, half of 4 squared is 4, minus 4 plus 3, so we get x plus 2 squared minus 1. So our turning point is minus 2 minus 1. So my range, let's write it all down. Domain, range. My domain of f is 0 to infinity. My range is 1 to infinity. My domain of g is all real numbers. My range is from negative 1 to infinity. Now that's if we didn't have this restriction. However, we want to restrict it because this, I'm trying to find the range of g is a subset of the domain of f. So we want this to fit into this. So we know f of x has to be greater than, the range of g is a subset of the domain of f of x. So we know that g of x has to be greater than or equal to 0 because we want this to fit into this. Okay, so if we want our range to be from 0 to infinity, g of x has to be greater than or equal to 0. So let's factorize that. X plus 3, x plus 1 is greater than or equal to 0. If we give it a quick sketch, negative 1, negative 3, there's our function. Now it says c has to be negative, and it's from negative infinity up to some value c. So here's negative infinity coming up to some value c. It's got to be that value there. C is equal to negative 3. It can't be negative 1, because between negative 3 and negative 1, we have a negative value, which we don't want. We only want our range to be between 0 and infinity here. So c equals negative 3. That will mean G has a domain of negative infinity to negative 3, and then it has a range of 0 to infinity, which means that the range of g of x fits into the domain of f of x. Find the value of c in part B, state the range of f of x, for the value of c. Okay, so we know if we've got these values negative infinity to negative 3, then our range is from 0 to infinity, which is the same as the domain of f, 0 to infinity, which means that our range is just going to be 1 to infinity, because these values produce this output. This output is then substituted into this function, and then that's the output from that function. So because our domain and range are the same, our range here and our domain here are the same, that means that the range of f of g of x is going to be the same as the original function, which is the range of f of g of x is from 1 to infinity. Okay, state the range of f of h of x. So let's say domain, range, f of x, h of x. F of x is 0 to infinity, and our range is 1 to infinity. And then h of x is all reals, and then our range is 3 to infinity because it's a parabola. So f of h of x, we'd actually have to restrict it because that fits into that. So that does fit into that, so we don't have to restrict it. But what it means is the function f of x, we're only going to be using values from 3 to infinity in the function f. Okay? So when I sub values into the function f, we're going to be using values from 3 to infinity. We can work out what f of h of x is. So f of root x plus 1, x squared plus 3 is root x squared plus 3 plus 1, which is x squared plus 4. Okay, so the domain of h of x is going to, because it's f of h of x, the domain of h of x means I can use all real numbers. They're the values that it would spit out. And then, so I can use all real numbers for this function. So if I use all real numbers for this function, have I stuffed something up? Is it minus 1, plus 1, plus 3, plus 4? Okay, so we know we can use all real numbers. X is an element of all real numbers because this fits into this. If we use all real numbers on this function, its lowest value is going to be when x equals 0. So when x equals 0, f of h of 0 is, when I sub 0 into this, I get root 4, which is 2. And then if I sub any other number that's bigger, this is only going to get bigger because when you square a number, it's going to get bigger. So my range of f of h of x is from 2 to infinity. Because as I put larger numbers in, greater than 0, underneath the square root is going to become bigger, and when you square root a larger number, it just results in a larger number. Okay, so that's composite functions. Possibly the hardest topic early on in methods. Well, it's definitely the hardest topic early on in methods. Hopefully you understand. And make sure you do all the questions in the chapter, and then make sure at the end of the year this is something you really focus on, because I can guarantee you it'll be on the exam. Okay, good luck with that. You can always send me an email, andrew@wma.com.au, if you're unsure on how to do a question. Okay, bye.